Okay, so, you kids, we're going to talk about, this is the beginning of trigonometry, and trigonometry stands for triangle measurement. How many of you guys have done the unit circle before? Or what? Oh, good. So this chapter is basically about unit circle and finding angle measured in degrees and radians, and graphing sine and cosine functions and things like that. And then we get into the more complicated part of trig in chapter 6. But but this is kind of the meat of this semester, okay? The meat and potatoes. All right. So anyway, angles are defined as a rotation of a ray, okay? So if we were to start with an angle, let's say, so like this, and if they say that a ray, it's a, what's a ray? It's a set of points that starts at one point and goes infinitely in one direction. Okay? And so if I want to so here is a ray. There's a ray. Okay? So an angle, if I were to draw an angle is defined as the rotation from here to here. Okay? And so when we're talking about the unit circle and the trigonometry that we're going to be talking about. So the standard position, the vertex at the origin and the initial side is the positive x-axis. So if I take this ray and rotate it this way, and counterclockwise is positive and clockwise is negative. Okay, so we start here along the x-axis and we rotate that way. So this might be an angle of, say, 40 degrees or something like that. Okay? And so standard position, vertex is at the origin, initial side, positive x-axis, and this is called the terminal side. Terminal is where it ends, right? So terminal is the end position, and so this is the terminal side of that angle. Okay? Coterminal angles we'll talk about in a minute, but they are angles with the same initial and terminal side. So for example, I can have one angle going this way at 40 degrees, but I could have another angle going this way, which would be how many degrees?
Negative 320.
Very good. That would be negative 320 degrees. And that would be, you guys understand that, right? And that would be, because you're going in the negative direction, and it starts at the same initial side and ends at the same terminal side, okay? Like it says here, and you could have another coterminal angle that if I went around this circle twice. So with trigonometry and with the unit circle, you could go around the circle more than once, whereas when we were in geometry, we only defined an angle as something between 0 and 180 degrees. But now we have angles that are bigger than 180 degrees, more than 360 degrees, and stuff like that. Okay? Positive angle, like I said, is clockwise. Negative angle is counterclockwise. And one rotation around the circle is 360 degrees, or 2 pi radians. Okay? Radians are just another way to measure angles in a circle, and they work out very nicely for doing trig problems. Okay, so it's just like you can measure things in centimeters or inches. You can measure angles in radians or degrees. Quadrant of an angle is determined by the quadrant and the angle of the terminal side lies. So you guys know that this is quadrant 1, quadrant 2, and quadrant 3, and quadrant 4, right? You know that. Yes? Okay? And so, sketch each angle and blah, blah, blah. So let's try to do that. That's pretty easy, I think. Let's see. Make this bigger. Take a picture of that. So, what happened? Oh, I want to place capture. Picture face capture version. Okay, so now if I do this, there we go. So 45 degree angle, that I think is pretty easy, right? Let's see if I can do this right. Yeah. Here's my X. Here's my Y, I guess. And so 45 would be, let's do different colors. About there. Yes?
Yeah.
Is that hard? That's a 45 degree angle. Where would a negative 90 degree angle be?
Down.
Down here, right? So this from here to here would be, I could just draw it. From here to here would be negative 90. And then
What quadrant would that be?
what? Oh, that's in either quadrant. You just say that's on the axis, on the y-axis. Okay? And then 225, well, that's 180 plus 45. So 225, I believe, is going to put you straight over here, right? So that would be 225 from here over to there, 225 degrees. And then 405, where would that be?
45.
Very good. That would be 360 plus 45 more, right? And so that would be the same, it would be, have the same ending point as 45, the same terminal side. So 405, I might say, oh, I go like this and around and end up back there. So that'd be 405 degrees. Okay? We're good?
Yeah.
Okay. So the other way, sometimes you'll have an angle like 1,060, 50 degrees or something like that. The best way to figure out where the terminal side is divide 360 in there, right? And see how many times it goes in. So 360 would go in there 3 times, 2 times? 2, 7, 20. So if I subtract, I get 330. So 1,050 degree angle would be the same as if I went around the circle twice, and then went 330 degrees more, which would put me 30 degrees shy of the x-axis. You get that? Yeah. So that's the way you can figure out that. All right, what's next on this sheet? Degrees, minutes, seconds. Okay, so to break down degrees into minutes, instead of using decimals, you can put degrees in decimals, or you can put them into minutes and seconds. And a minute is 1/60th of a degree, and a second is 1/60th of a minute. And the symbols that they use to indicate it are these things here, the little one, what's that called? Apostrophe, and then quotation marks, I guess, for the minutes. Okay? And so to convert, what you have to do is you have to go 15 degrees plus, that's 30/60ths, right? So that would be 15.5 degrees. Yeah? Because it's 30/60ths of 1 degree, because each minute is 1/60. To do this is 27, my pen is losing its power. 27 degrees plus 12/60ths of a degree plus 38 what's?
60 squared.
60 squared. So it's 1/60th of a 60th for a second. So this is 36. That's like that. That's how you do that. I'll show you a trick in a minute, but not yet. Okay? And I have these answers somewhere. Wait, I have to pause. No, not yet. Now I'm going. Okay, so if you plugged all that stuff into your calculator, you would get 27 point 212121055 degrees. Okay? Now to go backwards, it's a little more complex. Okay? And so if I have 25, 256.37, okay? What I need to do, basically, I'm going to get a bigger.
Are there multiple ways to write it?
What do you mean?
Like if you're going the other way, then you write it.
As what?
Never mind.
So if I want to change this into minutes, okay, this is going to be 250. The pen is running out or something. 256 degrees plus 30. You go the opposite way. Since it's I have to remember this. You multiply by 60, right? So it's 0.37 times 60 minutes. But if you do that, you get a remainder, okay? So if you do that, 0.37 times 60, you get, does someone have a calculator? 0.37 times 60.
Wait, are you purposely adding the 0.37?
Yeah, because it's 250 degrees plus some amount of minutes. So take 0.37 and multiply by 60 for it. What do you get? 22.2. So this is 256 degrees plus 22 and 22 minutes and plus 0.260ths, right, of a minute, or not 0.260, yeah, so if I multiply that by 60, I'll get how many seconds it is, okay? So it's 256 degrees plus 22 minutes plus 1.2 or 12 plus 12 seconds, or just 256 degrees, 22 minutes, and 12 seconds, like that. All right? Now, you should know how to do that by hand, but there is a cheater way to do that. You want to see the cheater way?
Of course.
Of course you do. Okay. So I have to pause it. We're going to take it. So if I want to do this on my calculator, what I can do, if I want to convert each angle into degrees, I can go 27, and then you go second, where's the angle? It's somewhere over here. Angle degrees. See that? You with me there? 27, angle is right above apps, right here. 27, 12, second, angle, and minutes is the little, right there, it's number 2. And I'm doing this one, I'm converting it into decimals. 27.2, and then I go second, oops, and then I want to go 38 seconds. 38, whoops. And seconds, you have to use the 2 hash marks. Where are they? Down, somewhere down here. Where's the 2?
Oh, on the plus. Oh, alpha.
Above the plus sign?
Yeah.
So you have to go alpha plus, no, not alpha plus. Yeah, alpha plus. So you go alpha plus, and there's your seconds. You see that? It's not in that menu with the angle for some reason. And then if you hit enter, then it converts it into 27.21055 degrees. Now to go backwards, okay, all you have to do is go second, angle, and see this DMS, dumb math stuff, that stands for. You just hit enter, and it should change that back into degrees, minutes, seconds. See that? okay, DMS. So that's a way for you to use that, but I want you to be able to do it by hand too. All right, so then the standard unit of an angle at which the arc, a radian, is the standard unit of an angle at which the arc of the circle has the same radius as, same length as the radius. So what does that mean? I'll show you a picture of what that means.
Yeah.
Okay? And so if I were to draw a circle, and I'm very good at drawing circles, watch this. Okay? Look at that circle. Okay? And if I take my tool here and so if I draw an angle here and an angle here, okay? And if I were to measure this arc, okay? And if I were to measure this radius, just take a ruler and measure. When the length of this arc is the same length as the length of this radius, that this angle is 1 radian, okay? And they don't usually put the units with radians, they just leave it. So they'll say that angle is 1 or that angle is pi or something like that, okay? So that's what a radian is. So if I were to do this out, it comes out that there are 2 pi radians in one circle, okay? So all the way around, there are 6.28 of these angles per circle, okay? Radian angle. So the standard unit, blah, 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 what do you get when the radius is 1? So in this case, theta is in radians, okay? Arc length of a circle. And if you go all the way around, that is 2 pi radians, okay? So if I plug in a radius of 1 and an arc length, or an angle of 2 pi, how many radians do I get? What's 1 times 2 pi?
2 pi.
2 pi. So if this is 1, the distance around the circle is 2 pi. This S means arc length, okay? And arc length is the distance from here to here. Okay? What do you get when the radius is 1 and theta? Oh, I already did that, didn't I? When theta is 1, I'm sorry. So when theta is 1 and the radius is 1, you get 1. You understand that? Sorry, so I kind of got ahead of myself. I answered this question. This question should have been 2 pi. Okay? This question, if both things are 1, what is the arc length? 1. Okay? So if the angle is 1 and the radius is 1, then this length is also 1. And that's what this says. Okay? So that's that. All right. Moving on to bigger and better things. Okay? To convert, find the length of the arc of a radius 2 meters intercepted by a central angle of 0.25 radians. So you just use this formula, S equals R theta. So back in geometry, you might have learned S, or the arc length, which sometimes they called L, is equal to 2 pi R, right? Remember that? Or
Yeah,
N,
pi
sorry,
times
not
diameter.
N over 360 times, not, sorry, that's wrong. N over 360 times 2 pi R. That would give you the length of an arc, okay? We have a much simpler formula when you're dealing with radians, but you have to plug in that angle in radians, not in degrees. So if I'm doing that, I plug in 2 in here and 0.25 in here, and I end up with 0.5 would be the length of my arc. So what that's saying, if the angle is 0.25 radians and the length of the radius is 2, then I have an arc length of 0.5. Okay? To convert radians, degrees to radians, you multiply by pi over 180. Got it? So for example, if I wanted to change 60 degrees into radians, I get 60 goes into 180 how many times?
3.
Pi over 3. You guys understand that? Okay? I just divide by 180 and multiply by pi. And you leave things in terms of pi. You don't want to round off to 3.14159 or anything like that. 150, I'm going to multiply by pi over 180, which is this. What goes into both 150 and 180? 30 is a nicer one, right? So you want to divide, 30 goes in there 5 times and 30 goes in there 6. So this is equal to 5 pi over 6. See that? Okay? With this one, okay, pi over 180, how many times does 45 go into 180? 4. So this would be negative pi over 4. Yes? Okay? And 107, that doesn't come out to be a nice neat one. So for this one, 107, you would actually have to do that on your calculator. So you could go, for that one, you would actually have to do 107 times pi. Pi is up here. I can't see the screen. Where's pi? Above the, here? Pi divided by 180, and you get 1.86 radians. And you don't have to put radians, you could just put 1.86 because it's assumed. Now another very useful thing to remember that works really well, pi over 6 is 30 degrees. Okay? Pi over 3 is, since there's 2 pi radians in 180 degrees, pi radians in 180 degrees, right? Then there are 60 degrees. Pi is the same as 180 degrees, okay? Pi over 4. What's 180 divided by 4?
45.
45 degrees. Pi over 2 is 90 degrees. And pi is 180 degrees. So it's really nice to know these things, because if they say something like 2 pi over 3, right? 2 pi over 3 is 2 of these. So how much would 2 pi over 3 be? If 1 pi over 3 is 60, how much is 2 pi's over 3? 120. And if pi over 4 is 45, how much is 3 pi's over 4? 45 plus 45 plus 45, which is, so that's the way I like to do these things, okay? Pi over 6, you can multiply by 180 over pi, or you should really just memorize that pi over 6 is 30 degrees, okay? So that's 30 degrees. Or you can multiply by 180 over pi and cancel things out. 3 pi over 2, well, if 1 pi over 2 is 90 degrees, how many is 3 pi's over 2? 270 degrees, okay? And over here, if 7 pi over 3, if pi over 3 is 60, then 7 pi over 3, what's 60 times 7?
420.
Other than Cameron. Cameron's the only one in this one, okay?
So you got
420. And then 3 radians, that doesn't have any pi's in it, okay? So the way you have to do this is with your calculator. 3 radians, then I have to multiply by 180 over pi, and then you go, that's 540 divided by pi, and then you divide that with your calculator, okay? Questions on converting? That's easy, maybe? I hope so. Okay, I'm trying to rush because I want to get through all this stuff. And now we have two more things. Okay? Glasgow, Montana, it's 48 degrees north latitude. Albuquerque, 35 degrees south. 5 minutes north latitude. Assuming that the radius of the Earth is 3690, find the distance between the two cities. So the way you do this one is you assume that the Earth is a circle. All right? And you draw a picture of a circle. And here it is. And which is more north? Albuquerque. But they're assuming that the radius, they find the distance between the two cities. So what they're saying is these two cities are in the same, what do you call those things? Longitudinal lines. Okay, so they're directly above each other, north-south. So one city is over here, kind of up this way. Here's, what's this? Albuquerque? Albuquerque. I've been there. Here's Albuquerque. And Montana, Glasgow, Montana is 48 degrees north. So here's Glasgow, Montana. Okay? And the way you find this angle is you subtract this latitude minus this latitude. So theta is going to be 48 degrees, 9 minutes, minus, this is the angle theta right here, okay? Minus 35 degrees, 5 minutes, okay? Which gives you 13, is that right? 13 degrees, 4 minutes. Follow that?
Yeah.
Okay? So, and then you know that the radius of the Earth is 3960. So I want to find the distance between these two cities, which is basically this arc length right there. So I'm going to use the arc length formula. S equals R theta. But this needs to be in radians. Okay, so I'm going to go S equals 3960, which is the radius of the Earth. Theta is 13 degrees, 4 minutes. But I'm going to multiply that by pi over 180 because that angle needs to be in radians. You understand that? Okay? And so then on my calculator, the way this is going to look, okay, I'm going to go 3960 times 13 second angle degrees. Hold on. What? This? Oh, I don't think it matters. I think I want to just change this into radians first, okay? So I'm going to go, first what I'm going to do, I'm going to go 13 second angle degrees, 14 second angle minutes, okay? And when I hit enter, that's going to turn that into a decimal form. See that? 14. All right. 13 second angle degrees, 4 second angle minutes. Okay? And then when I hit enter, what? Come on. Well, I hit degrees twice. Minutes. Okay, now when I hit enter, that turns it into a decimal. And I'm going to multiply that by pi over 180. Times second, pi is here, that pi? Pi divided by 180. And with multiplication and division, you don't have to put in parentheses, but I'm just going to do that. Times 3960, and I hit enter. And so that tells me that those two cities are about 903.1 miles apart. Okay? Which is about right, I guess. I don't know. I've driven to Albuquerque. All right. Two more things. The next thing we use is this area of a sector formula, and this has to be in radians. Oh, just one more thing. It says find the area of a sector of a circle of radius 2 formed by an angle of 30 degrees. So again, this needs to be in rads. All right? So we have A, and you guys remember what the sector of a circle is?
Yeah, but it looks like.
Okay. Yeah, sector of a circle, they're talking about watch this. Watch my great techniques here. I can shade this in. So this is a sector of a circle, a piece of the bottom. So they want to know that area. And that comes out of that formula n over 360 times pi r squared, which is the area of a circle. But they just convert this into radians. Okay? So to do that, this is going to be, in this case, 2. How many radians is 30 degrees? Looking back, how many radians is 30 degrees? Pi over 6 is 30 degrees. Okay? You should memorize that one. And then, so, getting back to here, it's just be 2 times pi over 6, which comes out to be pi. What happened to the 1/2? I forgot about it. That's what happened. Okay? So, A equals 1/2 times 2 times 2 squared, times pi over 6. That's better. Which gives you 2 pi, because it's 4 divided by 2, over 6, which is pi over 3 square feet. Okay? You understand that? Just plug it into this formula. Okay? So R is 2, square it, divide by 2, and theta is the angle in radians. And that's the way you do it. And there's all your homework. And remember, you heard it here on Mr. Leader's Cutting Edge YouTube channel. That's all.